In this molecule we have a ring. There's a couple of wedged groups on it, and you really need to be careful if you have chiral centers in an acyclic molecule or groups on one side of a ring. Because if I draw this in kind of a slightly different viewpoint, and we think about the chlorines are out, which we can equate those to being upward. And then we have hydrogen that are kind of downward on the bottom side of the ring. What you see, hopefully, is that you have this top side of the ring and the bottom side. And those are two different environments. On the top side of the ring, things will interact with these chlorines that are pointing up. On the bottom side of the ring, you don't have those chlorines, making for a different environment. So what that means is hydrogen on one side of the ring will be distinct from hydrogen on the other side of the ring. Now this compound does have a plane of symmetry we have to be aware of. The symmetry plane runs right through the middle. Let's draw in the hydrogens. We have a back hydrogen here, a back hydrogen here. Then on the next carbons, we have an out and a back, out, back, out, and back. So like we've been doing, let's start with the hydrogen on these carbons. These hydrogen, we have one on the left, it's back. The one on the right is on the other side of the mirror plane. It's equivalent, so that's also type A. Now we come further around the ring. We get to these carbons, which are mirrored. The hydrogen that are out represent one type, so this would be B. The other out hydrogen on that carbon is also B. Those are up close to the chlorine. They see the chlorine's environment. The back hydrogen are distinct, type C. Those are down on the bottom of the ring, away from chlorine's environment. And next we get to the CH2 group. At the very bottom, we have the out hydrogen, which is D. It's out in the same direction as the chlorine. The back hydrogen is E. It's back away from the chlorine. So this molecule has 5 distinct types of hydrogen. When we go to do the carbon, it actually becomes a little simpler because you don't have carbons above and below the ring. We just have the carbons that are part of the ring. So if I redraw this, we still have our plane of symmetry. Now it's a little simpler because we just need to go through and figure out the carbons. Here's one type. It's mirrored on the other side of the plane. Here's the next type, which is mirrored, and then the third type is down here at the bottom. So we have 3 distinct types of carbon.